Okay, we're going to move away from doing statistics and talk about probability. This section is basically going to be introduction to probability. The probability of some event occurring, the probability that some event happens, some event happens, it occurs. Well, assuming that the outcomes are equally likely, that is, if you roll, well, let's not talk about even rolling a die. The numbers on a die are 1 through 6. The chances that you get a 1 is the same, if you roll a die, the chances that it comes up 1 is the same as if it comes up 2, it's the same as if a 3 came up, etc. They're all equally likely, assuming it's not a loaded die, that is, assuming it's a fair die. A loaded die is called a biased die. As long as it's not biased, each of these numbers, 1 through 6, are equally likely to come up. If you ran this experiment, if you rolled, the experiment being rolling a die, if you rolled a die 600 times, most likely, on average, each of these numbers will have come up 100 times. That's what I mean by equally likely. If all the events are equally likely, and you want to talk about one of these events, some event happens, well, in the bottom is the number of total outcomes. And in the top, the numerator is the number of favorable outcomes. So for example, tossing a die. The probability, or you toss a coin, you roll a die. The probability, which is, so this is how you write the probability of rolling a 6. That's how you would write in shorthand the probability of rolling a 6. Just like you've had f of x, the bracket means of. P means probability. Probability of f of, and then you read what's inside, f of x. So it's the probability of rolling a 6. Well, the number of favorable outcomes, the number of total outcomes are 6. Either you roll a 1 or a 2 or a 3 or a 4 or a 5 or a 6. And these outcomes have to be equally likely. There's 6 equally likely outcomes. How many of those equally likely outcomes are favorable? Favorable is what's inside the parentheses. It's a 6. Well, there's only one way of rolling a 6. There's only one favorable outcome. It's this one right there. Now, if I ask a different question, what's the probability of rolling an even number? Well, there are still 6 outcomes. I meant to put that in the denominator. There are 6 total outcomes, equally likely outcomes. How many of them are even? Well, the 2 is even, the 4 is even, and the 6 is even. 3 of them are of this type, the favorable type. What's in here is favorable. Okay, so it's 3 over 6, or 1/2. Half the times you're rolling even, half the times you're rolling odd. Okay, there's 3 evens and 3 odds. Why would you think that you'd have a better chance of rolling an even than an odd, or rolling an odd has a better chance than rolling an even? The outcomes have to be equally likely to use that very top formula. Now, someone may say, well, the probability that it is raining right now where you live is 1/2, because the bottom should be 2, because there's only 2 outcomes. Either it's raining or it's not raining. Hence the 2 in the bottom. What about the numerator? Numerator is the number of favorable outcomes. Well, I do agree there's 2 outcomes. Either it's raining right now, or it's not raining right now. So there are 2 outcomes. That's why there's a 2 in the bottom. But only one of them is favorable. Raining right now. That's this one. Raining right now, not raining right now. So someone may say, well, it's 1 out of 2. The thing is that the chances that it's raining right now and the chances that it's not raining right now are not equal. They're not equal. Possibly the probability that it rains is 1 out of 10. And the probability that it's not raining is 9 out of 10. Out of 10 times, 1 time it's raining, 1 time it's not raining. If I randomly call you up on 10 different times and I ask you, is it raining or is it not raining? 1 time you'll tell me it's raining, and 9 times out of the 10 you tell me it's not raining. They're not equally likely. That is why it's not 1/2. The probability that it's raining is 1/10, not 1/2. Okay, the events, these total number of outcomes, each of those outcomes have to be equally likely. Each of these outcomes have to be equally likely in order to use this rule. Okay, suppose you have a family, or you want to have a family. In fact, you want to have 3 children. And you want to know the probability that you have exactly 2 boys, or the probability that you have exactly 3 girls. So again, you having 3 children, and they're either a boy or a girl. Now, the first child can be a boy, and then the second one can be a boy or a girl. Well, let me start off differently. The first child can be a boy, or it can be a girl. And then the second child, if it's a boy, the second child can be a boy or a girl. If the first child's a girl, the second child can either be a boy or a girl. After having a boy and then a boy, you have your third child. Either it's a boy or a girl. After having a boy and then a girl, you have another child. It's either going to be a boy or a girl. Same thing down here. After having a girl and then a boy, the next child can be a boy or a girl. After having a girl and then a girl, you can have a boy or a girl next. Okay, what I have here, this whole mess, is called a tree diagram. You have to be able to read a tree diagram. Boy, boy, girl, boy. Boy, boy, boy. Boy, oh boy, oh boy. Or you can have a boy and then a boy and then the girl. B, B, G. Or you could have had a boy and then a girl and then a boy. Or a boy and a girl and then a girl. You could have had boy, girl, and after boy, girl, you could have had a boy or a girl. That's the top one. Probably should have put it on the top. Now we're down to the next one. You can have a girl and then a boy and then a boy. Or girl, a boy, and then a boy. Or you could have had the girl and the boy and then a girl. A girl, a boy, and then a girl. Or you could have had a girl, and then a boy. Girl, then a boy. Or you could have had girl, and then a girl. Okay, those are the 8 outcomes. So now these here are the 8 outcomes. And to know that there's 8 outcomes, we'll talk more about this next section. But for the first child, there's 2 outcomes, boy or girl. For the second child, there are 2 outcomes, boy or girl. Same for the third outcome. If you multiply those 3 numbers, you get 8. And that's the number of outcomes. There are 8 different outcomes. 1, 2, 3, 4, 8, 7, 6. That's not a 6, and a 5. Okay, there are 8 different outcomes. And I listed all of them. I even numbered them. Except I haven't numbered them correctly yet. But I'm going to take care of that right now. There you go. Those are the 8 outcomes. Somebody asked you, and they're each equally likely. It's just as likely that you'll have a boy, girl, and boy as it is having 3 girls. Or having girl, boy, boy. They're all equally likely. Someone may say, well, no, that's not true. It's less likely to have 3 girls than to have boy, girl, boy. Well, that's not exactly true. If I ask you, what's the probability that you have 2 boys? Yes, this is one outcome, but there's others. Number 2 has 2 boys. Number 5 has 2 boys. Those are the only ones that have exactly 2 boys. Exactly is a big word. Exactly 2 boys. Out of the 8 outcomes, 3 times you have 2 boys. Now, what's the probability that you have exactly 3 girls? Well, out of the 8 equally likely outcomes, only 1 time do you have 3 girls. So yes, the chances or probability that you have 3 girls is less than the probability that you have 1 girl. If you have 2 boys. Remember, if you have family, if you have 3 children and you have 2 boys, that really means 1 girl. Probability that you have exactly 1 girl is going to be the same as the chances that you have 2 boys. Because think about it, if you have 2 boys, then you had 2 boys and a girl. What's in these brackets, given that you have 3 kids? What's in this bracket may say exactly 2 boys, but it means 2 boys and a girl. If I tell you I have 3 children here and I have exactly 2 boys, well, that tells you I have 1 girl. Same thing here. If I tell you I have 3 children and I have exactly 1 girl, that means I had 2 boys. Okay, what's in those brackets in both of those cases on top are exactly the same. They both say 2 boys and 1 girl. Exactly 2 boys means 2 boys and a girl. If you have 3 children, exactly 1 girl means you have 1 girl and 2 boys. Okay, so the probability that you have 2 boys is 3 times the probability that you have 1 girl. But that's because there are 3 of these. There are 3 cases where you have 2 boys. 2 boys, exactly. Number 2, number 3, and number 8. But each one of them has a probability of average chance. All like probability of you know it's out of 8. Now, a quick way of figuring out that there's three cases. The quickest way of realizing that there's three cases is to think, well, if you have exactly two girls, then you had one boy. And it's easy to list the ones with one boy. You either put a boy in the first position and girls elsewhere, or you put the boy in the second position and girls elsewhere, or you put the boy in the third position and girls elsewhere. You should be able to think about that in your head without even writing it down. Two girls means one boy. This means exactly one boy. And that boy can either be born first, second, or third. So there's three cases, 3 out of 8. Or you can count them. Exactly 2 girls. Well, here's one case where you have exactly 2 girls. Here's the second case, and here's the third case. Here, the boy was first. Here, the one boy was second, and 2 girls. And I want the one boy third. And here's where you have the one boy third. Either the first one's a boy, or just the second one's a boy, or just the third one's the boy. That way you can count more quickly and realize it's 3 on the top. The one thing that I don't like is when students, after doing, say, one of these probabilities, when they're asked the second one, sometimes they don't need to do any work, but yet they do work. For example, a probability of exactly 2 boys. Okay, if you worked it out, you'll see it's 3/8. That is, you look at the sample size, or the sample. BB girl, boy, girl, boy, boy, girl, 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 boy, 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 girl, girl, boy, girl, girl. There are the 8. Exactly 2 boys. Well, these have exactly 2 boys, and these have exactly 2 boys, and so do this. And you say, oh, the answer is 3/8. Wonderful, you got it right. Now, if somebody asks you, what's the probability that you have exactly 1 girl? You don't have to go back here. You don't have to say, oh, let me write down this chart again. I'll just erase it. Let me write this down again. There it is. And now I want exactly 1 girl. Well, this has exactly 1 girl. This has exactly 1 girl. And here's exactly 1 girl. Oh, it's 3 out of 8 again. You don't need to do that. You need to start being more mathematically mature and realize that if you have 3 kids, exactly 2 boys, this really means 2 boys and 1 girl. Okay? Exactly 1 girl out of 3 children means 2 boys and a girl. 2 boys and 1 girl. You're finding the probability of the same 2 events. In this one here, you're finding the probability of 2 boys and a girl. Sorry. In this one right here, you're finding the probability of 2 boys and a girl. Well, you better believe you're going to get the same answer. I don't want you to spend time trying to count. Oh, this does not have exactly 1 girl. This one does. This one does. This one has 2 girls, so not 1. This one has 1 girl. This one does not. It has 2. This has 2 girls. This has 3 girls. Only these 3, and 3 on top, have exactly 1 girl. You don't need to do that after you did the top one. Okay. Next I want to talk about, maybe I should have done this before, about what type of values you can get when you do probability. Now, remember that 100% means 0. And in case we need it, 100% equals 1. And 0% equals 0. The probability, suppose what I put in here won't happen. Suppose you're 60 years old. Okay? Suppose you're, actually, let's say 98. Suppose you're 98. The probability that you will play in, will, not did, will in the future. You will play in the NBA. That is, you will play professional basketball. It's 0. It is not going to happen. It's not going to happen. Suppose you take your test and the highest grade you can get is 100. The probability that you get 100 or less, what's the chances that that happens? Isn't it certain that it will happen? Isn't it guaranteed? Again, the premise is you take a test where the highest score is 100. And then I ask you, what's the probability that you'll get 100 or below, or 100 or less? It's guaranteed to happen. I mean, if you didn't get 100 or less, that meant you got more than 100. But you can get more than 100. The highest grade, I said very clearly, is 100. That's the premise. Suppose the highest score you can get is 100. And then somebody asks you, what's the probability that you get 100 or less? It's certain. It's guaranteed. What's the probability that you get or score over 100%? Well, let's just say it's no percent. It's 0 to 100. What's the probability that you get over 100? Well, that won't happen. There are only, you can't get above 100. You can get 100 or below. The highest grade is 100. So you can't get over 100. That would contradict that the highest score is 100. You couldn't possibly get over 100. What's the probability that right now it's raining or not raining? What probability can also be percentage. You know, if the probability of some event is 3/4, I don't care what it is. It doesn't matter. What I want to say is that every number, especially 100 or below, can be written as a percentage. So what's the percentage of times that if you looked at your window right now that either it's raining or not raining? Okay, won't it be 100%? For you to say no, it won't, it can only be 90%. Well, then there must be another outcome, other than raining or not raining. Well, you can say, come on, it can be snowing. Fine, it's snowing, but then it's not raining. You can say, oh, it can be sunny outside. Well, then it's not raining. You can say it's hailing outside. Well, some of you may consider hailing rain, which means it is raining. Some of you may say, you know what, I think hail is not rain. Fine, so then it's not raining. Some of you may say, well, I'm not sure. It's either one or the other. Well, the probability that this or that happens is 100% or 1. Probability is always between 0 and 1. It's not going to rain 150 times, it's not going to rain 150%. You can't tell me that you have 150% chance of passing your stat class. You may have 100% chance of passing your stat class. You may have 18% chance of passing it, You may have an 80% chance of passing. You may have a 0% chance of passing. You know, like if it's towards the end of the semester, the only thing that comes up next is the final, and you had 100% on all your 50 exams, and even if you get a 0 on the final, you still have at least a D average, so you're going to pass. That person can walk around and say, I'm going to pass statistics. 100% chance. That doesn't mean they're going to get a high grade. It just means they're definitely going to pass. The other end, you have a student who failed each and every exam, and even if they get 100 on the final, they still have a 22 average. Well, they're going to fail. It's guaranteed. It's certain. What's the probability that they will fail? 1. What's the probability they will pass? 0. And things in between, like, well, maybe they'll pass, maybe they won't. Maybe I'll pass, maybe I won't. Well, that's going to be between 0 and 1. The probability of an event is less than or equal to 1, but bigger than or equal to 0. These symbols mean in between. The probability of any event is in between that number and that number. Somebody writes this. A lot of students, the teachers tell them, this is red, 3 is less than x, which is less than 7. And they have no understanding of what it means. This means x is in between 3 and 7. It cannot equal 3. It cannot equal 7. If it did equal 7, or could equal 7, I would have an equal sign there. This tells me that x is in between 3 and 7. It can equal 3, but it can equal 7, but it cannot equal 3. That's what that tells me. X is in between 3 and 7. That you have a failing form. Thinking of a number. I'm calling the number x, and x is in between 3 and 7. That has meaning to you. X is in between 3 and 7. If you just read this as 3 is less than x is less than 7, has no meaning to you. But thinking x is in between 3 and 7, that's strong. Probability of any event is either 0 or 1 or somewhere in between. It's never more than 1, and it's never negative. That means less than 0. This isn't ever negative. Okay, that completes this section on Introduction to Probability. Next section, we'll do some more heavy-duty problems.